Number 8, graph the inequality 5x plus 3y is less than x plus 6. So the first thing we always want to do is graph the boundary line. 5x plus 3y is less than x plus 6. Now this inequality is a little goofy because we've got variables on both sides. It's not in slope-intercept form. We don't have y by itself. It's not in standard form. We don't have all the x's and y's on the same side. So we kind of have to make a decision. I'm going to choose to put this in slope-intercept form. So I'm going to go ahead and solve for y. The first thing I want to do then is get rid of my x's. And I'm just doing this to create a nice boundary line. We get 3y. And instead of a less than, when we're trying to think of this as the boundary line, let's just treat it like it's an equals. You got 1x minus 5x, that's negative 4x. And we still have that plus 6. Now to cancel out the times 3, we'll divide by 3. And if we earthquake this, negative 4x divided by 3, we just have negative 4/3 x. 6 divided by 3, that's 2. And now I can see this in slope-intercept. My y-intercept is going to be 2. The slope is negative 4/3. So I go down 4 over 3 to find another point. The boundary line, we decide if it's dashed or solid by looking at the inequality symbol. In this case, it's just less than. So we'll have a dashed boundary line. And then we have to decide where we're going to shade. So test a point. As long as 0, 0 is not on the line, go ahead and test it. 5 times 0, 0, plus 3 times 0, well, that's still 0. Is 0 less than 0 plus 6? And the answer is yes. So since the point 0, 0 works, we want to shade that entire side of our boundary line. Anything in the shaded region, the coordinates x and y will satisfy this entire inequality. In terms of describing it, we do just nick quadrant 1, there's quadrant 2, 3, and 4. We hit all the quadrants, but we exclude the boundary line, looking like letter F.